Hello, myself is Kumar and I welcome to you in my class Physics. Okay, and today we will solve some problems which is based on the JMNs and needs which has already asked in the previous exam. Okay, then now see the questions we will do some questions today, and the question is mainly from the electrostatics class 12 physics from chapter 1 and 2. We will see that. Okay, so now see questions. The first question will see a square of side capital L meter is in the plane of the paper. A uniform electric field E volt per meter also in the plane of paper is limited only to the lower half of the square surface. See figure, it is given here. Okay, the electric flux in SI unit. So what we have to find is electric flux. We have to find units associated with the surfaces. In this question, it is said that the uniform electric field is passes through the plane of the paper is the square which is placed in here. Okay, which is plane placed in here, and that electric field which is passes through the half of this square. Okay, if this case is given here, and we have to find the electric flux in unit associated with the surface, and options are given here. The first option is 0, next option is EL square, third option is EL square by 2 epsilon naught, and option 4 is EL square by 2. So now see electric flux. Okay, see now how to solve this problem. See electric flux. Electric flux, it is the amount of the electric lines of force which is passes through a certain what is this area which is given. Okay, in a area is the amount of the field which is passes through it. Okay, then the flux which is given is E vector, and here what is D. Okay, vector E and ds, and where your E is electric field, E is electric field. Okay, and ds is area vector. ds is area vector. Okay, and flux is equal to, since it is the dot product, therefore it will become E ds cos theta. So now see the E ds now cos. Now angle will be what? Now this angle is between the area vectors and field. Area vector and what it is? Field. Okay, then how to find the angle now? See, okay, so now see this is the square plane is here. Okay, the plane which is in the plane of the paper, and the area vector is always perpendicular to the plane vector. Now see, so area vector is perpendicular, it is outward. Okay, in this direction it is outward. Now see, the plane vector is outward, and the field of line is passing through in this way. The field is passing through in this, means that this area vector directions and field is perpendicular to each other. तो ये दोनों क्या है? परपेंडिकुलर है. तो ये एरिया वेक्टर का डायरेक्शंस कहाँ पे? आउटवर्ड की तरफ में ऐसा है, और फील्ड का डायरेक्शन कैसा है? ऐसा जा रहा है. ओके, तो मीन्स नाउ से तो इस तरह के यहाँ पे ये बन रहा है यहाँ पे एंगल, दैट इज द 90 डिग्री. दिस इज द एंगल 90 डिग्री. ओके, so now see the angle is 90 degree, since your theta is equal to 90 degree, which is equal to cos 90 is equal to 0, and whole answer will be 0, and your correct answer is 0. Okay, this is a very important say this is a AIPMT में आया हुआ questions है, which is a very important मतलब very important question for the JEE mains also, जो अभी बहुत जल्द होने वाला है. Okay, तो now see, तो यहाँ पे see now, तो don't be confused in here. Okay, the theta is the angle between the area vectors and field of lines. तो यहाँ पे क्या है? area vector इस okay in this directions में है, and field ऐसा यहाँ पे है. तो both are the perpendicular to each other. Okay, so now come to the next questions. An electric dipole of dipole moment P is lying along a uniform electric field E. The work done in rotating the dipole is 90 degree. Okay, and the work done, so we have to find an angle. Rotating angle is given by reason 90 degree. Now see, it is the work done. Okay, the work done. Now since since let us consider the uniform electric field, okay, and the dipole we have to take, and this here we have taken the minus and here we have taken the plus q, and here the force F1, and here the force is due to the minus q, which is F2, and here the perpendicular line we have to draw, and the angle is theta. Okay, so now it is the amount of the work done by rotating this dipole. Okay, rotating this dipole, and the length between this one, let it is A and let it is B, and the distance between A B is given by 2L. It is a twice of L. Okay, and since the since the torque, so what we have to find the work done. The work done means it is a twisting. Okay, the work done by twisting say particles means the dipole, it is given by the torque. It is given by the torque. Okay, so now see, in this case the torque is given by the P cross electric field. Okay, the dipole moment cross electric field, which is in vector, and given by the torque is given by the Pe sine theta. And since the angle of the rotation, which is already given, it is 90 degree by 90 degree, then your torque is equal to Pe sine 90 degree. And since we know that the sine 90 is 1, then answer will be Pe. The option 2 is the correct answer. Okay, the next questions, let's see. The two parallel large thin metal sheets have equal surface charge densities sigma equal to 26.4 into 10 to the power minus 12 coulomb per meter square of opposite sign. This electric field between the electric field between these sheets are. So what we have to do, the two opposite the parallel plate is given, okay, and between these two the plate, parallel the plate, thin plate, what we have to find is electric field we have to find. Okay, so now see how to see these questions, now how to solve this question. Okay, it is consist of the two parallel sheets. The parallel sheets are here. Okay, two parallel thin metal sheets have equal surface charge density sigma, and it is sigma, let it is A and it is B. Let it is B. And what we have to find? What we have to find is the electric field between these two plates. The electric field between the two parallel plate is given by, okay, it is given by electric field is equal to surface charge density by epsilon naught. Okay, the electric field between the two parallel plate, which is given by the sigma surface charge density by epsilon naught, which is equal to sigma, which is given surface charge density 26.4 into 10 to the power minus 12 coulomb per meter square by epsilon naught 8.854 into 10 to the power minus 12, 10 to the power minus it is 12. Okay, then answer we get nearly, so nearly will get 10 to the power minus 12, 10 to the power minus 12 will get cancel. तो ये दोनों क्या हो जाएगा, cancel हो जाएगा, both will cancel, and nearly it is 2 is the 16, 24, 25, 26 means approximately we will get 3. Approximately 3 we will get, and unit of electric field is Newton per coulomb. Okay, it is a Newton per coulomb, since electric field is given by the force by charge, and force is Newton and charge is coulomb. Newton per coulomb, and correct answer is option 3. Okay, the next questions which is asked since AIMS entrance exam में पूछा गया. Okay, the spatial distributions of the electric field lines due to the charge and B. Okay, this is A and this is B. Is shown in figure. Which one of the following statement is correct? Okay, so now see the following statements are okay. It is given here on the basis of this figure. So we have to find out which option is correct. And since in figure it is giving the passings of the electric field of lines, and since we know that electric field of lines always starting from the positive charge and ending in the negative charge, and this is A is positive since it is the origins of the electric force of lines. Electric field of lines, force of lines is positive and its end at negative. And since A is positive and B is negative, okay, first criterion for this one. And next is now see the number of the lines which is leaving from A is 1, 2, 3, 4, 5, 6. And the number of field of lines which is coming here, which is entering at B is 1, 2, 3, 4. So therefore the density of A, okay, the magnitudes of the A is more than the magnitudes of B. Options 1 is the correct answer. Options 1, it is given A is positive and B is negative. It is positive since we have found out here, and this is negative since we have found out here, and magnitudes of A is more than the B because the line of force which is leaving the A is more and entering at B is less. So therefore the correct option is option A, 1. Okay, now see next questions which is also asked in AIMS entrance exam. Okay, so now please see the question. क्वेश्चन ठीक से पढ़ लो, देख लो एक बार ठीक से. देखो ये क्वेश्चंस बहुत इंपॉर्टेंट है, ओके, एंट्रेंस के लिए, जेईई मेंस के लिए भी और नीट के लिए भी. अभी तो सारा मतलब एम्स पीएमटी सारा एक ही एग्जाम कर दिया, नीट. ओके, तो लेट्स सी. ओके, तो क्या बोल रहे हैं यहाँ पे, ए हॉलो सिलेंडर हैज ए चार्ज क्यू. तो चार्ज क्यू इज प्रेजेंट हियर, चार्ज क्यू इज प्रेजेंट हियर, लोकेटेड विदिन इट symmetrically. Okay, if phi is the electric flux in units of voltmeter associated with the curved surface B. Okay, the flux linked with the plane surface A in units means what we have to find the flux which is linked with the plane A. And since now in this figure the flux of A and flux of B are both are equal because it is already it is mentioned it is symmetrically. Okay, तो क्या है यहाँ पे, ये जो फ्लक्स ऑफ ए एंड फ्लक्स ऑफ सी दोनों क्या हो जाएगा, इक्वल हो जाएगा. क्यों इक्वल होगा, बिकॉज इट इज ऑलरेडी मेंशन हियर, क्या बोलो, सिमेट्रिकल है यहाँ पे. ओके, देन चलो नाउ लेट्स स्टार्ट. ओके, हाउ टू सॉल्व दिस वन. ओके, तो नाउ सी सॉल्यूशन. Okay, now flux, the total flux we have to find out here. Then flux, let's take the help of the Gauss law. Okay, so Gauss law is what it says. Okay, the total flux which is equal to 1 by 4 pi, sorry, total flux which is equal to 1 by epsilon naught times of the charges. Okay, again, okay, again I'm saying that. Okay, so now see again listens once. The charge, according to the Gauss law, the charge, okay, the charge, okay, charge by epsilon naught means the flux is equal to 1 by epsilon naught times of the charge. Okay, so flux is equal to Q by epsilon naught. See, directly from the Gauss law. This from where it has came? Okay, Gauss law. तो Gauss law से आया हुआ है ये वाला. तो now see the total flux. The total flux is what it is now here. So what we have to do now next? The flux of A plus flux of B plus flux of C is equal to Q by epsilon naught. And since we have to find the flux which is linked with the surface A, the flux A plus flux C, we have to write the flux A plus flux B. Flux B is, see, if phi is the electric flux in units voltmeter associated with the curved surface B, means the at B surface the flux is phi is equal to Q by epsilon naught, and since flux A is equal to flux, what is B, because already it is mentioned there, it is symmetrically. Okay, so now see how many flux A are there, the twice of flux A, okay, equal to Q by epsilon naught plus flux, well, going there it will become the minus flux. Okay, then what we have to find? Flux A. The flux A is given by 1 by 2 under bracket Q by epsilon naught minus, okay, flux. Now just see the right answer. Okay, right answer. Okay, yeah. Okay, the option 2 is the correct answer. Okay, I think you have understood, you have got the answer now, how to do. Okay.